If you look at the famous King's Chamber, its walls and its roof, the ceiling of the King's Chamber are all made with gigantic granite blocks.
If you step inside the King's Chamber of the Great Pyramid of Giza, you'll find massive granite blocks, each weighing as much as 70 tons. Mainstream archaeology says ancient Egyptians cut and fitted these enormous blocks using copper tools and stone pounders. But for more than 2 decades, one man has relentlessly challenged that explanation. His name is Graham Hancock, a best-selling author and researcher. For years, he traveled across Egypt, from the Great Pyramid to the granite quarries of Aswan, from the underground chambers of Saqqara to museums filled with ancient artifacts, all in search of one answer. How were these massive granite stones really cut? And what he found wasn't a hidden machine or a lost blueprint. It was something far more unexpected, evidence hidden inside the stone itself. So what exactly did he discover? And how does it challenge the story we've been taught for generations? Let's dive in. Testing the official explanation. If ancient Egyptians really carved some of the hardest stones on Earth using only copper tools, stone pounders, and sand, could we repeat the same process today? This is the first question that comes to the mind of every researcher, scientist, and anyone who has ever stood before these ancient monuments and wondered how they were actually made. A leading expert in recreating ancient Egyptian techniques tried to recreate the process themselves. But before we look at those experiments and their surprising results, we first need to understand the stone itself. Because granite is not just another rock. It is one of the hardest natural stones ever used in ancient construction. Much of its strength comes from quartz crystals, giving it a hardness of around 6 to 7 on the Mohs scale. To put that into perspective, diamond, the hardest natural material on Earth, sits at 10. Copper, the metal ancient Egyptians are believed to have used, sits at only 3. And that creates a serious problem. A softer metal simply cannot cut a harder stone the way a knife cuts through wood. Against the quartz crystals inside granite, a copper blade bends, wears away, and slowly disappears. But here's something most people don't know. The traditional explanation isn't just one idea. There are 2 common versions of it. One suggests that copper tools, along with a lot of time and effort, were enough to shape the stone. The other argues that the copper wasn't really doing the cutting at all. According to that explanation, the copper tool acted more like a holder. Sharp quartz sand was poured between the tool and the granite, and as the tool moved back and forth, those tiny quartz grains slowly scratched and ground away the stone, much like sandpaper smooths a piece of wood. At first, that sounds reasonable, but the closer you look, the more difficult the explanation becomes. The cutting material couldn't be ordinary desert sand because it was too soft. It had to be sharp quartz sand. Also, those tiny grains quickly lost their cutting power, meaning workers would have needed a constant supply of fresh abrasive throughout the process. Now imagine doing that, not for one small object, but for some of the largest granite structures ever built. Inside the Great Pyramid of Giza, the King's Chamber is supported by 9 massive granite beams, some weighing up to 70 tons. They were quarried in Aswan, transported hundreds of kilometers, then cut and fitted with remarkable precision. Also, if copper tools were constantly wearing away, the Egyptians would have needed enormous amounts of copper simply to keep making new ones. But during the Old Kingdom, copper was a precious resource. So instead of debating the theory, researchers decided to put it to the test. In 1999, experimental archaeologist Dennis Stocks recreated ancient Egyptian cutting techniques for the PBS documentary Pharaoh's Obelisk. Using copper saws and sharp quartz sand, he demonstrated how the process was believed to work. And it did work. Stocks successfully cut granite using this method. But there was a catch. The process was painfully slow because the copper tools wore down rapidly. His experiments showed that removing just 1 cubic centimeter of granite could wear away roughly 2 to 3 cubic centimeters of copper. That result only made the mystery deeper, because the question was no longer whether ancient Egyptians had the skill. They clearly did. The real question was, how did tools that wore away so quickly create stonework that has survived for thousands of years? And surprisingly, the answer was not found in ancient workshops or forgotten tools. It was hidden in the cuts, grooves, and marks left behind on the stone itself. The machine-like marks. In 1880, British archaeologist Sir William Flinders Petrie arrived in Egypt. But unlike many explorers of his time, he wasn't chasing hidden treasure or royal tombs. He wanted something far less exciting. At least on the surface, he wanted measurements. Petrie believed archaeology should be built on careful records instead of guesses. His obsession with precision would later earn him the title Father of Sequence Dating, changing archaeology forever. Wherever he went, he carried measuring instruments, including a custom-built micrometer capable of detecting incredibly small differences that most people would never notice. That attention to detail led him to something almost everyone else had ignored. While studying the granite around the Great Pyramid, Petrie came across several discarded drill cores, the solid stone cylinders left behind when a circular drill cuts into rock. One of them, now known as Granite Core Number 7, looked like nothing more than construction waste, until he measured it. Wrapped around its surface were perfectly even spiral grooves, not random scratches, not broken marks, but one continuous spiral running from top to bottom, almost like the threads on a modern screw. But that was only the beginning. When he measured the spacing between those grooves, he realized something even stranger. Based on the geometry of the cuts, Petrie calculated that the drill had advanced into solid granite by roughly 0.1 inches, or about 2.5 millimeters, with every single rotation. That number may not sound extraordinary, but engineers know it is. Even many modern core drills fitted with synthetic diamond tips, operating under controlled mechanical pressure, struggle to match that depth of penetration in granite with every turn. So Petrie asked the obvious question: what kind of force would it take to produce marks like these? Achieving that level of penetration would have required more than 2 tons of constant downward pressure, over 4,000 pounds, applied evenly throughout the drilling process. But that leads to an even bigger problem. A thin, hollow copper drill, the tool traditionally associated with ancient Egyptian drilling, should have buckled or collapsed long before reaching anything close to that force. At this moment, Petrie didn't claim he had discovered a lost civilization. He simply documented the evidence of what he saw. But more than a century later, that same evidence landed in the hands of a famous precision engineer. And what he discovered next changed the entire conversation. The engineer's evidence. That engineer was Christopher Dunn. An aerospace machinist from Manchester, England, Dunn spent more than 50 years manufacturing high-precision components for the aerospace industry. So when he looked at ancient Egyptian stonework, he wasn't seeing it as an archaeologist. He was seeing it through the eyes of an engineer. One of the first things that caught Dunn's attention wasn't the Great Pyramid. It was a collection of more than 40,000 ancient stone vessels scattered across museums around the world. Most of them were made during Egypt's pre-dynastic period, even before the pyramids were built. Centuries later, Pharaoh Djoser gathered thousands of these vessels and stored them beneath his step pyramid at Saqqara, where they remained hidden for more than 4,600 years. At first glance, they looked like ordinary jars and bowls, but the closer Dunn looked, the stranger they became. Some have wide, rounded bodies, with necks so narrow that even a finger can barely fit through the opening. Yet somehow, their interiors were hollowed out with remarkably even walls. Others are so perfectly balanced that when placed on a flat surface, they naturally settle upright, because their center of gravity is almost perfectly centered. And that's not all. When modern 3D scanners examined several of these vessels, the results surprised even engineers. One detailed scan found that the overall shape varied by less than 15 microns, less than 1/5 the width of a single human hair, a level of precision that sounds almost impossible for objects made more than 4,600 years ago. For Dunn, these weren't just beautiful artifacts. He saw them as examples of engineering that could be tested, measured, and compared. That search eventually led him beneath Saqqara into the underground tunnels of the Serapeum, where 24 enormous granite and diorite boxes sit inside narrow chambers. Each box weighs up to 70 tons, while its massive lid adds another 30 tons. Dunn placed a certified straightedge against the inside walls and shined a flashlight behind it. The surfaces were so flat, they matched the reference standards used in modern machine shops. The interior corners met at almost perfect 90-degree angles, and the opposite walls remained remarkably parallel over several feet. But Dunn wasn't the only engineer to reach that conclusion. As more machining specialists examined Egyptian granite, they kept reporting the same thing: long, continuous cutting marks that looked more like the work of precision machinery than hand tools. To them, these weren't simply impressive ancient artifacts. They looked like evidence of engineering techniques that didn't fit the traditional explanation. But the engineering is only part of the story. The biggest surprise comes when you step back from the stones and look at the timeline itself. The lost timeline. Throughout history, civilizations usually improve over time. You can see that pattern almost everywhere. From early stone huts to castles, from wooden ships to steel warships. So, if the ancient Egyptians developed these remarkable skills themselves, their earliest work should have been their roughest, and their later monuments should have been their finest. But Egypt doesn't seem to follow that pattern. The greatest leap appears almost at the very beginning. During the 4th dynasty, Egypt produced the Great Pyramid of Giza, the Valley Temple, and some of the most precise multi-ton granite masonry ever seen in the ancient world. Then, something strange happened. Instead of improving, the quality slowly declined. The pyramids built during the 5th and 6th dynasties became noticeably smaller and less precise. Many were built with loose rubble cores covered by limestone blocks. Today, several have partially collapsed into little more than weathered mounds, while the much older Great Pyramid still dominates the landscape. The same pattern appears in smaller objects as well. Many of the finest stone vessels come from pre-dynastic and early dynastic Egypt. Yet thousands of years later, Egyptian craftsmen often produced simpler pottery and softer stone vessels that lacked the same remarkable precision. It's the opposite of what we'd normally expect. Instead of watching a civilization gradually master its craft, it almost looks as though it started at its peak and slowly lost something. Interestingly, even ancient Egyptian tradition tells a similar kind of story. Their texts speak of Zep Tepi, or the first time, a distant golden age when gods or divine rulers brought order, knowledge, and the foundations of civilization to Egypt. To mainstream archaeologists, these stories are symbolic religious traditions, not historical records. But to Graham Hancock and others who question the traditional timeline, they hint that Egypt's greatest achievements may not have been the beginning of the story, but the continuation of something much older. And that raises the biggest question of all. If the Egyptians inherited this knowledge, who were they inheriting it from? The civilization before Egypt. This is where Graham Hancock's theory takes a dramatic turn. He doesn't argue that the ancient Egyptians lacked intelligence or skill. Far from it. His claim is much narrower. He believes the earliest Egyptians may have inherited advanced knowledge from a civilization that existed long before the pharaohs, then preserved parts of it without fully understanding where it originally came from. According to Hancock, that civilization disappeared around 12,800 years ago, near the end of the last ice age, during a period scientists call the Younger Dryas. This wasn't an ordinary change in climate. Evidence shows the Earth went through a sudden period of extreme environmental upheaval. One leading hypothesis suggests that fragments of a large comet struck the massive ice sheets covering North America. Whether that specific impact theory is ultimately correct is still debated. But scientists agree this period saw rapid climate changes and the melting of enormous ice sheets. As those ice sheets melted, sea levels rose dramatically over the following centuries, flooding coastlines around the world. Vast areas that were once dry land disappeared beneath the ocean. And that's important, because ancient people almost always settled near rivers and coastlines, exactly the places that would have vanished first. Hancock believes that if an advanced maritime civilization existed before those floods, much of its physical evidence could now lie underwater, hidden beneath thousands of years of rising seas. But he doesn't believe every piece of evidence was lost. He argues that some survivors carried fragments of their knowledge to places like Egypt, where later civilizations preserved what they could. Interestingly, ancient Egyptian traditions contain stories that some researchers point to in this debate. One of the examples Hancock points to is the Edfu building texts carved on the walls of the Temple of Edfu. They describe mysterious figures, often called the Seven Sages, who are said to have arrived after their homeland was destroyed by a great flood, bringing sacred knowledge with them. Mainstream Egyptologists generally interpret these stories as mythology, not historical events. Hancock sees them differently. To him, these stories may preserve a distant memory of real people, survivors who carried pieces of knowledge from a forgotten world and passed them on to later civilizations. And if that's true, it could explain one of the biggest questions his critics still struggle to answer. Why do the oldest monuments often display the highest precision, while later generations seem unable to match them? Because if that knowledge wasn't first developed by the Egyptians, perhaps it was inherited. But no matter how convincing a theory may sound, in the end, every explanation, whether mainstream or controversial, has to answer the same question. What does the physical evidence actually show? The final clue. So, after everything we've seen, what is the one piece of evidence Graham Hancock keeps coming back to? It isn't a hidden machine. It isn't a lost blueprint. And it isn't some mysterious artifact locked away where nobody can examine it. It's the stone itself. The drill cores with their perfectly consistent spiral grooves. The granite beams inside the Great Pyramid. The enormous stone boxes beneath Saqqara, with surfaces so flat they surprised precision engineers. The thousands of stone vessels carved from some of the hardest materials on Earth, many with shapes and symmetry that are still difficult to reproduce by hand today. On their own, each of these discoveries raises difficult questions. Together, they reveal a pattern that's much harder to dismiss. And let's be clear about one more thing here. None of these are theories. They're physical objects that still exist today. They can be measured, scanned, photographed, and examined using modern instruments. The cuts are there. The geometry is there. The precision is there. And that's exactly where the debate begins. Mainstream archaeology has shown that ancient methods could shape granite through patience, skilled craftsmanship, and abrasive sand. But many researchers argue that those methods still don't fully explain every mark left behind, every remarkably consistent cut, or every object that seems to push far beyond what those tools should have been capable of. And that's the question Graham Hancock keeps returning to. Not whether the Egyptians were capable, but whether the full story of how they achieved these extraordinary feats has yet been discovered. Because this isn't about taking credit away from the ancient Egyptians. If anything, it highlights just how remarkable they truly were. Whether they developed these techniques themselves or inherited part of that knowledge from those who came before, they transformed it into some of the most extraordinary monuments ever built. And thousands of years later, those same monuments continue to challenge archaeologists, engineers, and historians alike, reminding us that the ancient world may still have secrets left to reveal. So, after all the measurements, the experiments, the engineering, and the competing theories, what do you think? Did ancient Egyptian engineers achieve these incredible feats using methods we've simply underestimated, or do you believe they inherited knowledge from a civilization lost to history? And if evidence of that forgotten civilization still exists, where do you think we'll find it first? Beneath the desert sands or beneath the oceans? Let us know what you think about this in the comments below. If you enjoyed this video, don't forget to give it a thumbs up. And if you want more incredible mysteries, discoveries, and evidence-based stories like this, be sure to subscribe to the channel. Thanks for watching, and we'll see you in the next video.